When we have a composite function, we combine two functions. So we've got f of x and g of x. F of x is x squared minus 1. G of x is x plus 2. Part A says find f g of x. When we have f g of x, we're putting our g function into our f function. So we do g first, and then we do f. So if we were going to put a number in, if we were going to put 2 in, we'll put 2 into our g function first. So g of 2, which would be 2 plus 2, 4. And then we'll put the 4 into the f function. So 4 squared, 16, take away 1, 15. So fg of 2 would be 15. We're going to do g first and then f. But we're going to do this just with the algebra. So we're going to put the whole g function into the f function. So our g function is x plus 2. So we're going to do f of x plus 2. So wherever we have an x, we change it into an x plus 2. So it's x plus 2 squared, take away 1. So that is fg of x. We could simplify it, so we could expand the brackets and simplify it, but I will leave it like that for now. Part B, find g f of x. So this time we're taking our f function and putting it into our g function. So our f function is x squared minus 1. So it's going to be g of x squared minus 1. So f of x is x squared minus 1. So we're putting that into g. So we're going to have x squared minus 1 plus 2, which is x squared plus 1. And part C says f squared, which is the same as ff of x. So we're putting f of x into f of x. So we're doing the f function 2 times. So we're going to put the input in, get out the output, and then put that in again and get the output out the second time. So we're putting x squared minus 1 into our f function. So it's f of x squared minus 1, which is going to be x squared minus 1 squared minus 1. And again, we could expand and simplify, but I will leave it like that. 3 for you to try. Pause the video, give them a go. So f of x is x squared now. G of x is 2x minus 3. Part A, we're putting g into f. So it's going to be f of 2x minus 3, which is 2x minus 3 squared. F into g. So it's going to be g of x squared. And that's going to be 2x squared, take away 3. So we're changing x into x squared. And g squared means g into g. So it's g 2x minus 3 into our g function. So 2 times 2x minus 3 minus 3. So 4x minus 6 minus 3, 4x minus 9. This time we've got f of x is the modulus of 3x minus 5. G of x is 2x plus 3 all over 4. We want to find fg of negative 5. So we're going to put negative 5 into g, and then put that answer into f. So we're going to do both functions. We're combining the two functions, but it's g first, then f. So let's work out g of negative 5, which is 2 negative 5s plus 3 over 4. 2 negative 5s are negative 10, plus 3 is negative 7. So it's negative 7 over 4. And then we're putting that into f. So we're going to do f of minus 7 over 4. And that's the modulus of 3 minus 7 over 4's. Take away 5. So type it in the calculator. So the absolute value of 3 times minus 7 over 4 take away 5 is 41 over 4. And solve fg of x equals x. So our function fg of x equals x, that's an equation. We're just going to solve it. So we're going to put g into f. So we've got the modulus of 3 times 2x plus 3 over 4 minus 5. So all in the modulus equals x. So we're just going to solve this equation. When we've got a modulus, we can have two separate equations for it, a positive version and a negative version. I think I'll simplify first. So let's do 3/4, expanding the bracket. So 3/4 of 2 is 6/4, 1.5. 3 over 2 x. 3/4 of 3 is 9/4. Take away 5 equals x. And 9/4 take away 5 is minus 11/4. So we have 3 over 2x minus 11/4 equals x. So we've got two possible equations here, a positive one and a negative one. So either 3 over 2 x minus 11/4 equals x, or the negative version equals x. So either one of them, and then we'll work out at the end if they work for this function. So let's take away x from both sides, plus 11/4 to both sides. So half x equals 11/4. Double both sides. So 11 over 2. So x is 11 over 2. Or for the negative one, we've got minus 3 over 2x plus 11/4 equals x. So we'll plus 1.5 x's to both sides. Then divide by 2.5. So 11 over 4 divided by 5 over 2 is 11/10. So we have two answers. So we've got 11 over 2 and 11/10. Do they both work for the question? So let's look at our modulus one again, which was 3 over 2 x minus 11 over 4 equals x. And check they both work. So the absolute value of 3 over 2 times 11 over 2 minus 11 over 4 11 over 2. So that one works. And 11/10 that one works as well. So they both work. So we've got two answers, 11 over 2 and 11 tenths. One for you to try. Give it a go. So f of x is 5x plus 1. G of x is 1 over x minus 2. X cannot equal 2. Find an expression for f g of x. So putting g into f. So it's the same as f of 1 over x minus 2. So that's 5 times 1 over x minus 2 plus 1, which is 5 over x minus 2 plus 1. Solve fg of x equals 11. So this equals 11. So 5 over x minus 2 plus 1 equals 11. Take away 1 from both sides. Times by x minus 2. So we have 5 equals 10x minus 20. Add 20 to both sides and divide by 10. So x is 2.5. 2.5, 5 over 2. F of x, different notation, but it means the same thing. So f of x is e to the power of x plus 1. G of x is our natural log, x minus 3. And we need to find in its simplest form f g of x. So we're putting g into f. So we're putting g into f. So wherever we have x in our f function, we're changing it into the natural log of x minus 3. So f g of x is e log x minus 3 plus 1. Now e and the natural log are inverses. They actually cancel each other out. So if we have e log 5, that is 5. If we have e log 10, that's 10. And it works the other way around. If we have the log of e to the power of 5, we have 5. They cancel out. They're the inverse of each other. So e log x minus 3 is just x minus 3. So it's x minus 3 plus 1, which is x minus 2. Finding its simplest form, g f of x. So we're putting f into g. So wherever we have x in our g, we're changing it into e to the power of x plus 1. So g f of x is the log of e to the power of x plus 1 minus 3, which is log ex minus 2. I don't think we can simplify that, so I'll leave it. One for you to try. Pause the video and give it a go. So f of x is e to the power of 3x. G of x is 2 log x. So find in its simplest form f g of x. So g into f. So our g function into our f function. So f g of x is e to the power of 3 times 2 log x, which is the same as e to the power of 6 log x, which is the same as e to the power of log x to the power of 6. So when we cancel out, e log cancels out, we just get x to the power of 6. Finding its simplest form, g f of x, so f into g, so it's 2 log e 3x, log e cancel out, so it's 2 times 3x, which is 6x. Composite functions again, so f of x this time is 3 minus 2x. We want to solve f squared of x, so f of x minus f of x squared equals 0. So let's do f of x first, f squared x. So f into f is 3 minus 2 times 3 minus 2x, which is 3 minus 6 plus 4x, which is 4x take away 3. So we have 4x take away 3 minus f of x squared, 3 minus 2x squared equals 0. Let's expand and simplify our 3 minus 2x squared. So 3 squared is 9. 3 times negative 2x, negative 6x. We've got that again, negative 6x again, and then plus 4x squared equals 0. We're taking away all of that though, so we've got 4x minus 3 minus 9 plus 6x minus 4x squared equals 0. So our x squareds, we've got minus 4x squared. For our x's, we've got 4, 6 and 6, that's 16 x's. And we've got minus 3 minus 9, which is minus 12. Let's divide through by negative 4 and get x squared minus 4x plus 3 equals 0. And then factorize x minus 1, x minus 3 equals 0. So x is 1 or x is 3. Okay, the same sort of question. One for you to try. Give it a go. So we want f squared of x first. That's f into f. So it's 2 times 2x plus 1, which is 4x plus 2 plus 1, which is 4x plus 3. So we've got 4x plus 3 plus 2x plus 1 squared equals 0. So 4x plus 3, expanding 2x plus 1 times 2x plus 1 will give us 4x squared plus 2x, so 4x in total, plus 1. So we have 4x squared plus 8x plus 4 equals 0. Dividing through by 4, we get x squared plus 2x plus 1 equals 0, which is x plus 1 times x plus 1. So x is negative 1.